Lesson number 52, Algebra 2, Chemical Mixture Problems, Type A. Okay, so no really easy way to do this except just get started with it. We have a container here, and we are dumping stuff out of this container into this bigger container. We also have this other container here, and we are also dumping stuff into this bigger container. So we've got blue junk and black junk that we're dumping in here. And when we mix blue and black together, we get this stuff there. Okay, so if I put 1 gallon of that and 2 gallons of that, I would have 3 gallons when I got it all dumped in. Alright, let's say that I want to dump in 10% of, they call it, in example 52.1, an iodine solution. So I'm dumping 10% of something in there. Okay, the other 90%, let's just say it's water. And let's say out of this one we're dumping 50%. So if we're dumping 50% of something here and 10% of the same thing here, we're going to come up with a percentage in here somewhere between here and here, right? Because if we brought 10% of something, it's going to dilute that. Or if we put this much, it's going to make this a lot more extreme. It's going to raise the percent. So we're going to have a percent in here somewhere between 10 and 50% when we're done. Alright, so what we've got is the amount of red junk that we're dumping in. So let's put a container here, and we're going to add this purple junk over here in another container, and that's going to give us our total amount from down here. Okay, so what are we doing? How much of each should the druggist use to get 100 milliliters of a solution that is 20% iodine? Okay, so when I'm done, I want 100 milliliters, which is written like this. 100 milliliters. So that is the amount of liquid I have here. So I'm going to put a quantity here, and I'm going to put a quantity here, add those together, and that gives me my 100 milliliters. Okay, so the amount I pour in from here, plus let's use this, let's call this the amount I pour, and let's call this the amount I dump, just so that we know. But we're putting it all together. So the amount I pour plus the amount I dump is going to give me 100. Okay, so that's the amount. But I'm pouring a 50% solution, so I'm going to write it as 0.50. And this one I'm putting in a 10% solution, so 0.10. Remember, whenever you use percentages, you have to change them to the decimal. And what do I want out of this? Well, the book says I want a 20% solution of this stuff. So I want 0.20 times my 100. Okay? So that is my formula. Okay, so if I take 50% of this, 10% of this, add them together, dump them into this big tank right here, I'm going to get 20% of, out of this 100 that I have here, 20, it's going to be 20% solution. So remember, I said it was going to be somewhere between these two, but look at, I'm going to get a 20% solution, so 20% is closer to 10 than 50, so I'm probably going to dump more of this in there in order to lower this all the way down to 20, but that's beside the point. There's my formula. So let's see if we can move this stuff up. Let's see if we can move my little tank here up. I'm kind of done with that. And there is my formula right there. Let's write it a little bit prettier. Okay, so there's my formula. Problem is, I have a P and a D, and I don't want two different variables. I want them to be the same. But what do I know about P and D? If I take the amount of that I pour plus the amount I dump, I will get 100, right? So I can set this equal to P or D, doesn't really matter. The book sets it equal to P, so let's go ahead and do that. So P equals 100 minus D, because we subtract that from both sides. So that means now whenever I see a P, like right here, I can put that in its place. And when I do that, something magical happens. Okay, maybe not too magical, but I only have one variable now. They're both D's, so I don't have to worry about two variables. So now I can solve this. So I'm going to distribute this and get 0.5 times 100, which is 50, minus 0.50D plus 0.10D equals 0.2 times 100 is 20. Okay, so there's my cool formula. Now I'm going to combine those right there. So let's go ahead again and move some stuff out of the way since the purple is all I care about. So I have 50, and if I combine what's in the box there, I'm going to get minus 0.40D equals 20. Subtract 50 from both sides because I'm trying to get D by itself. And since they're both negative, I can just make the negatives go away. Divide by 0.4. And that goes away. And my D is 30 over 0.4. So the amount that I dump in D is 75 milliliters. Okay? That's the D. Now I need to know how much I poured in. Well, if I end up with 100, and I poured in 75 from one that I dumped, then the other one's got to be 25. So that 25 plus 75 gives you 100. And that's pretty much it for that one. All right, let's look at one more example, and we'll call it good. Okay, so let's look at example 52.2, middle of page 227. All right, so let's look at what we've got here. A chemist has one solution that is 10% salt and 90% water. Okay, and then he has a solution over here that's 2% salt and obviously 98% water. And then right here we end up with, when we mix these two together again, the answer is going to be between what we added, 6% salt and 94% water. Alright, so what we're asking is how much of this and how much of this are we going to pour into here so that we end up with 1,400 milliliters. Okay, so same thing, exactly the same thing as the other one. Okay, what we're going to do here is we're going to write 0.10 times the amount of water we're pouring in. So that's there. Plus 0.02, changing the percent to a decimal, times the amount of water we're dumping in. And that's going to give us 6% of 1,400. Okay? And we know that the amount we pour in and the amount we dump in is going to give us a total of 1,400, and then we're going to solve for one of them. Okay, so that's what we're going to use. So instead of a P here, we're going to use 1,400 minus D from right there. That's going to be 0.02 D equals 0.06 times 1,400. And I will leave that up to you to figure the rest of that out, because you're just using distributive to get that, and then you're going to combine your D's, you're going to subtract, you're going to divide, you're going to multiply, and you're going to come up with a D, and that will give you how much you end up with. And in this case, you should get 700 when you multiply everything through. And then you had 1400. So if 700 of it is how much you dumped in, then the amount of poured in is also going to be 700, so that you get 1400 total. So that's it. You added the same amount to both solutions of both of them in order to get a 6% solution. Alright, so that's it. They're done the exact same way. The practice problem and numbers 1 and 2 are done the same way. So just follow these guidelines and you should be just fine.